Yeah, so what Remesh does in general is lets us understand a population. The way that we do that is that we take a live population, usually somewhere between about 100 and 1,000 people, and we're gonna have a back and forth dialogue with them on the time scale of minutes. So it means in every 1 minute or so exchange, we're gonna ask them an open-ended natural language question. And about a minute later, we wanna be able to say, here's what represents that population. And because it's open-ended, it means that we are going to have a large number of answers to that question on the order of the number of people that we have, so hundreds. And what we want to be able to predict, or we want to be able to show as results, is the fraction of the population that agrees with each one of those answers. Now, what makes this tricky is, given a minute or so, we're only going to be able to gather about 10 to 15 data points per person. So if you break that down, that means any one of the answers we want to know about will only have about 10 to 15 data points on it. If you're a stats person, you're going, that is not enough data to make an inference about the population without massive error bars on it. So the primary challenge we have to solve is, given this sparse amount of data that we can collect, because we only have a fixed amount of time to collect it over this really large number of responses, what data do we choose to collect that lets us predict what fraction of the population agrees with every answer the most accurately? So the technical problem that we often are solving is being able to predict the number of people in a population that agree with something. Now, you would intuitively think that the best data you could possibly have for this, given you can only acquire so many data points, is that all of those data points are about people and what they agree with. And initially we thought this might be the case, but we had done a lot of work in pair choice, which is not asking do you agree or disagree with something, it's asking, given these two things, which would you prefer? And so we asked ourselves this question, could it be that if you can only collect a fixed amount of data points and what you want is the fraction of the population that agrees with something, could it be better that you actually collect less data points about what people agree with in exchange for collecting a few more data points about people's binary pair choices? So we did this. We ran an experiment where we collected a bunch of both of those types of data. We then simulated a bunch of examples from that, where we would basically take away all of the binary choice and train only on the agreement data and look what we get, calculate accuracy of held out data. And then we would slowly turn up the fraction of those agreement data points that we replace with the binary choice data points, right? From 0 up to 100% of binary choice. And then we would plot the accuracy as a function of that ratio between pair choice and agreement. And what we found was actually really interesting, which is, intuitively you would think it requires the best data you can gather, the most efficient stuff you can get is knowing what people agree with, because you want to predict what people agree with. But it turns out that that graph looks like kind of like an upside down U, which means that somewhere between about 50 and 60% of agreement tasks and 40 to 50% of pair choice tasks is actually where we get the highest accuracy. So it leads to an interesting conclusion, which is that if you want to learn the most about a population, oftentimes, or in this case, it can be better not to ask them all of directly what you want to know, but sometimes asking other things because the model can make use of it.